In this video, we would like to investigate finding intersections of two graphs. So in the first example, we would like to find the points of intersection of the graphs of the equation y equals x and x squared plus y squared equals 1. Now note, both of these graphs, or these equations, have standard graphs that we should hopefully recognize. Y equals x is going to be a line with slope 1 passing through the origin, and x squared plus y squared equals 1 is a circle with center 0, 0 and radius 1. Will look something like this. What we need to do is find their points of intersection. So to find their points of intersection, we're going to proceed in a very similar fashion to finding the intersection of two lines. Use this method of substitution. Y equals x, so we can go ahead and take the x and plug it in for y in the second equation. So that will give us x squared plus x squared equals 1. So 2x squared equals 1. X squared equals 1/2. And x is equal to plus or minus the square root of 1/2. And what we need to do for each of these x values is find the corresponding y value. So we have two possible x values. We have x equals the positive 1 over root 2 and the negative square root of 1 over 2. And then the corresponding y value comes from plugging into the original equation. So plugging back into y equals x. So if x is square root of 1/2, so is y. If x is minus the square root of 1/2, so is y. And that gives us the 2 points of intersection. 1 over root 2, comma 1 over root 2, and minus 1 over root 2, minus 1 over root 2, which correspond very nicely to these points of intersection we've indicated in the above graph. For a second example, let's graph the equation of y equal x squared minus 2x plus 4 and y minus x equals 4 and find the points of intersection of their graphs. So let's think from an intuitive perspective here. Y minus x equals 4 is a line with y-intercept 4 and slope 1. Y equals x squared minus 2x plus 4 is a quadratic function. The leading coefficient is positive, so it opens upward. And if you were to sketch your graphing calculator by getting enough points and connecting the dots, this is what the two graphs would look like. Now let's go ahead and find their points of intersection. We have y equals x plus 4. Let's go ahead and plug this in for y in the second equation. So x plus 4 is equal to x squared minus 2x plus 4. And now what we would like to do is get all of the x's on one side. So how about on the right? So we need to subtract x and subtract 4. And this is very nice to work with because we see that an x factors out, leaving an x minus 3 on the right. And this would imply that x is equal to 0 or x is equal to 3. So in terms of our points of intersection, they occur when x is 0 or 3, and the corresponding y value is x plus 4, plugging into either equation. So when x is 0, y is equal to 4. When x is 3, y is equal to 7. And our 2 points of intersection, 0, 4, and 3, 7. And this corresponds very nicely to the points of intersection we see in the above graph.